Welcome to Section 5, Addition, Subtraction, and Complex Fractions. In this section, we're going to look at adding and subtracting rational expressions and also simplifying complex fractions. So first, I want you to think back on adding fractions. For instance, if we have 3/9 plus 4/9, we can add those together because they have the same denominator and just add the numerators to get 7/9. You have 3 out of 9, 4 out of 9, add them together, get 7 out of 9. Well, likewise, if we have 1/2 plus 1/3, we can't just add these together. We need to turn those into fractions that have the same denominator. So we ask ourselves, well, what's a number that 2 and 3 both go into? And we want to keep that number as small as possible, called the lowest common denominator, or LCD, and that number is 6. And so we ask ourselves, well, what do we do to 2 to make it 6? Well, we multiply by 3, so we multiply the numerator by 3 as well to get 3/6. That's 1/2. Same thing with 3. What do we have to do to 3 to get 6? Multiply by 2, so we get 2/6, and then the sum here is 5/6. So hopefully that's not too much of a stretch. You remember how to do stuff like that. We're going to do the same thing here with our complex fractions. The key is have to have same denominator in order to add. So let's take a look at a few examples. So first off, if we have 4 over 3x plus 5 over 3x, we ask ourselves, do we have the same denominator? 3x, 3x. Yes, we do, so we can just add to get 9 over 3x, but that can simplify. Cross that off, make that a 3, and this simplifies to 3 over x. Okay, over here, same thing. We look, x plus 3, x plus 3. Okay, it's the same denominator, so we can simply just subtract 2x minus 4 all over x plus 3. Now, at this point, we cannot simplify that anymore. There's not a factor that's the same that we can cross out, so it's just the quantity 2x minus 4 over the quantity x plus 3. Well, what happens if we have two different denominators? We have to find common denominators. So first, always factor the denominators, so that way you know what pieces are involved. So if we factor this, well, 6x squared can't factor that, and we could break it down into 2 times 3 times x, but we'll just leave it as 6x squared. However, this 4x squared minus 12x we can factor by taking out a 4x. If we take out a 4x, we're left with x minus 3. Okay, so we look at, well, we need a denominator that can include all of these pieces. So we ask ourselves, what's the lowest common denominator of 6 and 4? So over here, let's do it over here. Over here, we're going to write out what our LCD is. Okay, so the lowest common denominator of 4 and 6 will be 12, because 6 goes into 12 and 4 goes into 12. The lowest common denominator of x squared and x is x squared, because x squared goes into x squared and x goes into x squared. Well, we also need this factor of x minus 3, because that's included in this fraction here, and so we have to have that multiple included in our lowest common denominator. So this right here, 12x squared times the quantity x minus 3, is our common denominator. So we ask ourselves, how can we turn 6x squared into 12x squared times the quantity x minus 3? Well, we only do that by multiplying the top and bottom by 2 times the quantity x minus 3. And you can see that by multiplying the 6x squared and the 2, you get a 12x squared, x minus 3. That's our common denominator. Well, when we do that up top, we get 10x, the 2 times the x is 2x, times 5 is the 10x, minus 30. Okay? And then over here, we have to ask ourselves, well, how do we turn this into 12x squared times the quantity x minus 3? So we have to multiply by 3x. Multiply the top and bottom by 3x. So we get 3x squared over the 12x squared times the quantity x minus 3. And now that we have a common denominator, we can add these two together. Well, we get a 3x squared plus 10x minus 30. That entire expression is over one denominator of 12x squared times the quantity x minus 3. So then we have to ask ourselves, can we simplify this? And we cannot, so we are just going to leave that as such. Okay, so we found a common denominator, and then we turn each of the fractions into a fraction with that common denominator. Let's look at another example. Now we're subtracting, which subtraction, is just the addition of the opposite. So the operation doesn't matter. What's key is we still need to find a common denominator. So once again, let's factor this. Remember, you always want to factor to make your life easier. Well, if you factor this, hopefully it's not too much of a stretch, but it's just the quantity x plus 2 squared. And this is x plus 2, x minus 2. Okay, so what is our lowest common denominator? Well, this has x plus 2 times x plus 2. This has x plus 2 times x minus 2. So we know we have to have an x plus 2 squared in both of them, because this already has x plus 2 squared. We can't get any smaller than that exponent. Okay, and this has an x plus 2 in it, but it also has an x minus 2. So our lowest common denominator has to have an x minus 2 in it as well. So this is our common denominator. Well, what do we have to multiply this by to get to that? Well, just x minus 2. Multiply by x minus 2 at the top, and multiply by an x minus 2 at the bottom. Okay, over here, what are we missing? Well, we're missing an x plus 2. So if we multiply the top by an x plus 2 and the bottom by an x plus 2, then we can get what we need. So when we multiply up here, let's go ahead and FOIL. When we FOIL, we get an x squared, and then a minus 2x and a plus x, so that's minus x. And then a minus 2 times 1 is a negative 2, all over our quantity x plus 2 squared, x minus 2. And then over here, once again, we are going to have this same denominator. Come on, write a 2. And then when we multiply, we just distribute the 2. So this is simply minus 2x, and then we're going to subtract a 4 as well. So at the top, we just need to simplify, combine like terms. We have a minus x and a minus 2x, so that gives us x squared minus 3x. And then we have a minus 2 minus a positive 4, so that's minus 6, all over x plus 2 quantity squared times x minus 2. Once again, we ask ourselves, can we simplify this? And since we can't factor the top, we can't simplify it anymore, and that is it. The common denominator of the quantity x plus 2 squared times x minus 2, and our numerator is x squared minus 3x minus 6. Okay, a complex fraction. Complex fraction is simply a fraction that has fractions in the numerator or the denominator, or it could have both. In this case, it has both. Now, the book tells you to simplify these a certain way in turning the numerator and the denominator into just a single fraction, which would work, doing the exact same thing we just did, in finding a common denominator, all in that. Well, I'm going to show you a little quicker way that I think works a little easier and faster. So we're going to look at all the denominators, x plus 2, x plus 2, x, and find a common denominator from all of those denominators. Well, that's going to be x times the quantity x plus 2. Okay? We're going to multiply the top and the bottom by that. And so we ask, is that legal? Can we do that? Are we changing the value of this expression? And really, we just have x times x plus 2 over x plus, or excuse me, x times the quantity x plus 2. And that's the same thing. We're just multiplying by 1, so we're just changing the look of this and not actually changing the value. So when we do that, now notice I put it over 1, and I did that so you can see that you multiply the numerators by the numerators, denominators by denominators, numerators by numerators, denominators by denominators. Okay, so let's look at the top. When we multiply, this x plus 2 and x plus 2 cancel out. So we're just left with 2x. And in the bottom, now remember, we have to distribute to each term. We do the same thing. This times this quantity cancels out with the x plus 2. So that cancels with the x plus 2. So we're just left with x. And then do the same thing. Multiply this quantity times this quantity. The x's cancel, and so we get plus 2 times the quantity of x plus 2, so that's 2x plus 4. Well, we can simplify that by saying 2x over x plus 2x is 3x plus 4. And now that complex fraction has simplified into a nice succinct fraction of the quantity of 2x over 3x plus 4. All right, moving on to one final example here. This is an equation. This is an example of a complex fraction that's used in real life. F is the focal length of the lens of a camera. Okay, and if we call P the distance between an object that's being photographed and the lens, and Q is the distance between the lens and the film. All right, I'm not going to draw a picture here, but think of taking a picture of a tree that's in front of you. It's some distance away from you and the camera. That's P. And Q is the distance that you have between the lens and the film inside of your camera. So it's a very small distance. And the focal length of that lens is going to equal this ratio right here, this fraction. Well, that's a little messy, so we want to try to clean it up a little bit and make it look a little nicer. So once again, we find a common denominator for all of our fractions. Well, the top one's just 1 over 1, so we don't need anything. Here we have denominator of P, denominator of Q, so our common denominator is PQ. So let's multiply the top by PQ, multiply the bottom by PQ, and when we do that, we get our focal length is equal to the product of P and Q all over, well, PQ times 1 over P cancels out the P and just gives us a Q. And then PQ times 1 over Q cancels out the Q, and we're just left with a P. So our focal length is equal to the product of P and Q divided by the sum of P and Q. Okay, I know I went through that quickly. You may need to go back and look at these examples again. View this video again. Tomorrow you will have a quiz based on these examples, so please watch this video intently. Do your best to try to figure out how to simplify these complex fractions and add and subtract rational expressions. And then come into class tomorrow with any questions. Thank you.